Hello, this is Challenge 9 and we're Team Carboneers. This is our team composed of 6 different people with our team leader being Callum Giblett. With today's challenge, we're trying to help HS2 reach net carbon zero emissions. This will be done by finding good practices and innovative methods to distribute throughout the whole life cycle of the project. This will be done by using the data from completed projects and assets to create a normalized methodologies and benchmark this against other measures. Vision of our team is to be able to normalize carbon impact between different assets to obtain a benchmark and standardize the approach to analyze global warming potential of assets. With this new approach, we can look at the whole life cycle of an asset to drive future decisions based on innovation and breakthroughs, which result in reducing carbon and delivering net zero.
As part of the product discovery, we used the Miro software. In understanding the data that was provided by HS2, we also looked at the customer need, the vision, the customer persona, their values, and the creating features. Included in this, we also created a process flow which looked at the assumptions we need to make, the normalisation based on the greenhouse warming potential, the benchmarking that needed to take place and the input required from HS2, and the machine learning needed to identify low and high carbon materials. The assumptions that we had to make included adding a category type such as a bored tunnel, overbridge, embankment and footbridge. We also needed to include the units of measure and associated quantities with this. There are also some inherent assumptions within the data that we can't do anything about, however we have noted them here.
This slide covers the methodology used in our analysis. In the interest of time, I will not cover all of the points explicitly, but will highlight key points. We merged the data sets that were contained within the folders using Excel. We added in assumptions that were covered on the previous page in order to make a model that you could use for comparison based on asset information. We then checked correlation, which we tried to use a neural network to do, but found that the data was insufficient to produce meaningful results. We correlated to produce another model based on the total mass of a project. We produced 2 dashboards, one in Power Apps and Power BI, and the other using the Django framework in Python. And then we had 3 further points of methodology that we were unable to address due to the time constraints within this challenge.
So for the data, we have inserted asset categories, units of measurement, and dominant quantities. These were not existing in the main data set, and that allowed us to collate data from 6 files together. And we were able to do pivoting for the resultant table to understand the levels of emission for the materials in different asset classes. These numbers are imaginary numbers to make the model work, and we were able to visualize this model in here, where we have the original data set, and then this data set down there is based on new data that is going to be input by the user through a Power App that we have developed, where you could insert new data, and then you would type the name of the project, the type of the asset, and then the carbon emissions in each and every single stage, and then that would feed in a SharePoint list, which is consolidated data MA edit, and that would feed in here, and then you could be comparing based on the project itself and based on the asset class between what's good versus what's existing. Thanks. So for the data, we have asset categories,
Here we show a polynomial fit of the project construction mass along the x-axis against the total global warming potential on the y-axis. Each of these lines is constructed using Excel to form a prediction of the GWP against each of the life cycle phases. This exact graph, the data is then being exported into the Python Django framework by a tool called Plotly. What this then allows the user to do is access it via a web interface, where they can enter their own project details down here. When they do so, it populates these markers, as you can see up here, where it says project demo, which allows them to make comparisons between their project and the expected norms and benchmarks are each of the lines for comparison.
So in order to progress our analysis further, we require access to additional project information. In particular, this includes the asset type, which was unspecified in the data, units of measurement and quantities of each element to refine our assumptions. In addition to this, it would be helpful to understand where the data is sourced from and to have a further expansion of the data sources so that we can more meaningfully make insights. How will your visualizations allow managers to decide on the best actions to take in order to reduce carbon emissions? So our visualizations will hopefully enable stakeholders to make decisions on which materials are the most beneficial to reducing carbon emissions for each asset and for every stage of the asset lifecycle. What steps could be taken to improve the quality of the data in the future? Alluding back to our previous slide, further asset specifications such as asset type and dimensions would be helpful. Other data sets, such as costs of individual assets, would enable us to optimize the carbon reduction against the potential economic impact of doing so. If you were to attempt this challenge again, is there anything you would approach differently? We would have utilized an earlier application of statistical analysis to determine correlations and produce plots that would give us a more intuitive understanding of the data. We would also try to ask more meaningful questions in the early stages, in particular about how the HS2 metrics, such as GWP, were derived. We also attempted to construct a machine learning model and deep neural network. However, the data proved to be too scarce to make meaningful insights from these.